So I just want to say a few words about Synaptic. The company's been around for more than 10 years. And when we first started the company, we did a lot of fixed price projects. Somebody would come to us and say, "Hey, we've got data. We think it can help us in the following way. Can you write code for us?" And so we would write code and deliver it, and they would be happy, and then we would go away. Over time, and actually pretty early on, we started getting into data engineering. We started working with Databricks quite a number of years ago, and that tends to be the platform that we go with these days. And so we sort of pushed backwards into the data engineering side of things and building data lakes and getting the data ready for the AI applications. And then slightly more recently, we've started trying to work on the user experience side of it. So if you're using AI systems to surface information to either internal consumers or customers that are externally facing, how do you do that in a way that makes sense? And so we kind of think of ourselves these days as a purveyor of intelligent products, right? We try and span the entire life cycle of AI-driven product development. Okay, so here's a slide which might be an appropriate lead in as an alternative title. It's AI is the peanut butter your outdated processes need. So I'm going to use a bunch of disjointed similes or metaphors depending on how I phrase them as we go through this thing. And I'm going to advocate for a viewpoint that might be, a little non-standard when you think about modernization and using AI, but we'll see if you believe it and kind of stick with it, right? But the idea is that instead of sort of replacing systems, which is typically what modernization kind of feels like, we're instead going to take that old system and kind of spread some of this AI peanut butter on top of it and make things better in a lot of ways. Now, I'm not going to claim that you never need to go in and replace systems. That's just wrong. But we're going to look at ways in which AI can be used to layer thinly on top of your existing code, infrastructure, software, processes, and try and move everything forward and make it better in kind of standard ways. So the outline's relatively straightforward. I'm going to talk about software and process modernization, kind of the old school way of doing it. And I'll sort of lean into the software modernization side of things a little bit more than processes. We'll definitely come back to processes. So, like what is it? Why do you do it? How do you do it? Then, after we've gone through that, I want to talk about, the shift in technology that has occurred over the past few years with generative AI and language models, and how that might lead to a shift in the mindset of how you approach modernization of a variety of kinds, but specifically focusing on business processes. And there we'll kind of introduce four new key capabilities that have become easy to use that I think are very relevant. Then we'll wrap up with some common pitfalls. How do things go wrong and how do you avoid that? We'll think about a framework for, if you wanted to embark on this journey, how would you do that? Where would you get started if you've got things that you want to modernize? And then we'll just have a few concluding thoughts. And I'll warn you that peanut butter is going to make an appearance in the concluding thoughts again. So software and process modernization, sort of what is old school, right? So if you just go to Wikipedia and say, what is software modernization? It's you've got old stuff, right? You've got old code, old programs, old anything that you're using inside your organization, and you're gonna rewrite it. You're gonna move it to a modern programming language. Maybe all the COBOL programmers are retiring and you can't maintain it. New architecture, so I'm going to build things in microservices or sort of new protocols and hardware platforms. The idea is that I've got this investment that I've made, and maybe the thing is it's running okay, right? But we're afraid to touch it because the three people who wrote it 30 years ago again have retired, and everybody's afraid to do anything with it. And so I've seen companies that really hesitate over that because they've got this thing that works and they don't really want to mess with it, but they feel like they need to kind of move forward with it. So, why do people modernize? A big one here on the lower left of those boxes is security vulnerabilities, right? So a lot of older code might not have been written with modern attack surfaces in mind, right? And so they might be more vulnerable today than they were in the past. You've got a lot of technical debt, so you've written things in a way that it forces you to do work that you would rather not do. You can't scale the systems. They're inefficient. That happens a lot. They just slow down through time. Not able to take advantage of modern hardware, for example. the technology is outdated. A big one is high maintenance costs. I'm paying a ton, either I'm paying a ton to try and maintain these systems, or they're not as efficient as they should be, and I'm just not able to get as much work done. People are being inefficient by virtue of having these older systems. And so if you look on the right-hand side, actually increased security was a big one. So why are people modernizing? We need more secure systems, or we need improved efficiency. Our people are just being slowed down by it, or we want to reduce costs, right? So lots of reasons why you would modernize. And it's super interesting because I was, kind of digging into the, internet and sort of reading a lot about modernization, and you cannot get away from R's, right? Like this is actually very common. So I got this from Radix, great article that this thing was in. I'm not denigrating it, but you lots of things you can do. You can rebuild. You can just say, I'm going to keep it forever. I'm going to retain the thing. Maybe I'll sort of rewrite the code. I'll kind of refactor things to make it more efficient. I'll wholesale replace it with a new system, or maybe I will rehost and I'll move it onto new hardware, and that new hardware is going to give me the boost that I want. So lots of ways that people think about sort of taking the old thing and trying to change it in some way. Like I'm gonna take the thing, and the thing I'm gonna modernize. And so we're gonna have a slightly different view. Here's this common pattern. It's the strangler pattern. The idea is that you've got this strangler fig. I think these things grow in Australia. There's a tree, and the strangler fig comes along and goes, "Yep, I'm going to start climbing up that tree." And then I start enveloping the tree, and then eventually the tree dies. The structure is still there, right? So the strangler fig wraps around the tree, kills it eventually, but now I've got this new structure in place, and the old tree doesn't go away until it's not needed anymore. And that's a really common kind of approach, right? So I've got a legacy system. I'm going to put some facade on top of it. That facade will sort of say, okay, I've got a legacy system and this sort of more modern thing. I'm going to arbitrate when do I call one versus the other. And then over time, what you do is you just sort of push more and more of the legacy code into the modern system, and then you can take off the facade and you just have this migration that's done, right? And so what I'm going to argue for, and what we'll get to in just a minute after another couple of slides here, is that, maybe the right thing to do is, instead of strangling, you can pull out the peanut butter, right? And sort of layer it on top of what you've got, and the old code can live on, but you're going to have really interesting, exciting new ways of accessing it and using it. So, you know, it's not easy to do this work. So here's an article from the Nebraska Examiner. It was about a project that was done in Idaho. And this is a 2024 article, and this is a ton of text, but what I'll do is I'll call out a couple of particular elements of it. So one is, in this system for the state, there were some programs that dated back to the 1980s, written in programming languages they don't teach in engineering schools anymore. Again, like, can anyone say COBOL, for example? Guarantee there was COBOL code running in there. They spent $120 million on this project called Luma, and things have not gone as planned, to put it mildly. And then here's a quote: "No offense. Anytime somebody starts out with no offense, it's going to be bad. This thing is a joke and it's not working." This, a House of Representatives member told legislators, right? And so articles like this abound, where people are gonna, like, we're gonna rewrite this thing. We're gonna spend $121 million on that, and it just takes forever. We did something like that. I teach at a university. Obviously, there are a lot of software systems that are used to sort of run registration and finance and lots of things. And we brought in a company, who shall remain nameless, to rewrite those systems, and it took forever, and the cost overruns were enormous. It was incredible. So what's the sort of the shift in technology, and the sort of shift in mindset that needs to happen? So what's happened, or how do you think about this? So modernization, it's not a platform, right? So it's not just sort of, you hear about lift and shift. It's not about picking this thing up here and moving it over here. It's an outcome. And so what you're doing is you are trying to optimize for the work that's being done. So, like, people are using the systems to get work done. I don't want to optimize the system. I want to optimize the work, right? I don't want to sort of, just making the thing faster isn't necessarily going to make it better. So you're not looking for just a new platform. You want the system that you're replacing, the process, to lead to better decisions. I want faster workflows. I want happier users. And so, one way to think about it is, your legacy system might not be the problem. It's kind of the seams between those things. And, everybody I think has experience, and I've certainly seen this in a lot of companies through the years where there's a spreadsheet, right? And there's a system over here, and there are people over here making decisions, and somebody controls a spreadsheet that pulls in data from a few sources, does some calculations, and then they hand it to the people who are making decisions. It's that kind of stuff that really slows you down, makes things hard, and leads to sort of all kinds of problems in terms of maintenance. And so we'll talk about how AI can help you deal with that, right? So the thing that's changed now is we've got generative AI, and it is cheap and incredibly effective. We can argue about cheap, but I would claim it's pretty cheap these days that we've had for sort of closing those seams, right? So what we're going to kind of argue for over the next, I don't know, 15 minutes or so, or 20 minutes is, you don't migrate. You want to AI, you want to apply it on top of what you have. And that is going to be a very workable solution in many cases. Now, I'm not going to argue that you should never replace anything. If you're running on a VAX mini computer and you're paying black market rates for replacement parts, you need to get off of that thing. But look at your processes and try and think about, is it sort of the connections between things that are killing me? And maybe I can put a little AI on there, right? I talked about peanut butter earlier. Now I'm talking about sewing machines, right? And try and sort of close those seams or make them less noticeable to users. And so that's what we're going to try and look at. So, like, why are we doing it now? What's changed? I think that the primary one is that language became an interface, right? So, used to be the case that if you had people that were going to interact with software of any kind, you had to have front end developers, and they are going to build beautiful interfaces that allow for fast and effective interactions. But now you can just say, hey, talk to this software and we'll kind of figure it out. So we've got these language models that can now deal with all the messy stuff that systems can't, and they can do it very easily. So, imagine an auto insurance adjuster who gets kind of a frantic call, and I've made those calls before, right? Like, hey, insurance person, I just had an accident. Here's what's going on. I need you to help me out. Then the insurance adjuster can go, okay, tell me what's going on, and you can automatically fill database fields based on that. It's also the case that reasoning is incredibly affordable. So things that used to cost $10 a query a few years ago cost pennies today. Those costs are continuing to go down. So, for example, a regional bank might buy a credit union and they've got customer records. And so now what I've got to do is I've got to figure out, is Tim Oates over here the same as Tim Oates over here? And now today, because of generative AI, I can do that dynamically in the call center. I don't have to go through all that work. I can have an AI system sitting there, helping me with that integration. So what are these key capabilities that I was talking about? And I've got a slide on each of these, and we'll definitely go through those. So, one is now we ask, don't query. Again, used to be the case that I worked with a person who was a big data SQL ninja at a startup one time. Everybody was like, you got a problem, you need to retrieve data efficiently from a massive database, go talk to this guy because he can do it for you. Now you just give natural language. You say, hey, giant database, I'd like to know the following thing, and it can go and compose queries for you. Now, there's still a role for these data ninjas because they can do things with respect to efficiency that I think modern systems have a hard time for. But for most query uses applied to structured data, you can just go language to a query and get it back. So ask, don't query. Then they're sort of reading the unread, which is we have a lot of unstructured data. So think about piles of documents, PDFs, medical records that have tons of text in them, for example. Now you can go unstructured to structured on demand. You can say, hey, language model, there's a pile of documents over here. Tell me something about the documents in aggregate, and it can go do it for you. Then on the lower left-hand side, gluing the ungluable, this gets back to this notion that you used to have to do formal integration, but now AI can kind of coordinate those coordinations across systems, do so dynamically as needed, and they're not constrained by whatever rules people came up with when they were trying to do formal integration. And then finally, deciding in context. So the recommendations that you might get can be delivered inside the tool that the user's already in. So if I'm in HubSpot and I'm, working on customers, I can actually have a window that pops up inside HubSpot. I ask it some questions, I get the result, and then that information can actually modify what's happening inside HubSpot. So I don't have to go from this spreadsheet over here that somebody built and then kind of manually enter it into HubSpot. So what I'd like to do is just to dig into each of those four. I've got one slide for each of them. But I'm going to start out with an example customer churn. So the idea is I got a business, I've got customers, and I'm trying to keep my customers loyal to me, but they leave for various reasons. So what often happens is that the signals are there. So I've got account history in a CRM. I've got tickets and complaints in a support system. I've got billing. I can look and see who's late on their payments because they might be ready to drop. Or I can look at my product and say, hey, what's usage look like? And has usage fallen off, for example? So often the data's there. And the process might look something like this. Somebody goes, hey, I don't know, I think there's a particular customer, maybe it's a B2B, and there's this business that's been with us for a while, and I think there might be a problem there. So I got to go, let me go ask the ops team, like, can I get data from you? They pull it from multiple systems, which is a manual process. Here's that spreadsheet that comes into existence in many cases. And again, this is far more common than you might believe. Some report is created, like, okay, now at some point a decision is going to be made. Potentially, I don't want to go back and ask for more information because that's going to slow me back down. And I'll take some action, but that action is often late because of the situation that I find myself in. So here's this process that has seams in it kind of all over the place. And the data's there. How can we make it faster? So first is this sort of ask, don't query. So now business users, they can ask questions in English. I can talk to a language model and say, assuming it's appropriately set up and there's an MCP server of the right kind, and the model can say, I hear what you're saying in English. I can translate that to SQL and hit your database. I can actually write Python code to wrap around some APIs and retrieve that data for you. The nice thing is that there's no training. Again, it's a business user is doing this, knows nothing about programming. Maybe they know something about programming, but they don't know enough to do this kind of task. There's no dashboard, there's no BI backlog, and it works wherever. So again, thanks to model context protocol servers, you can just slap those things onto anywhere there's structure. I can write a little bit of code, and that code is written in many cases for many of these kinds of systems and just literally talk to them. So the shift that you're going from is I need to submit a ticket to the data team to I'm just going to ask the question and get an answer back. And so the idea here is that the people that are close to the work, they become self-sufficient. So now somebody can be sitting there and say, which of my customers are at risk this week? That gets translated into a query to a database or a set of databases. And you go, hey, Tim, he's high risk. His usage is down. He's submitted 3 support tickets recently, and there's a late payment. So on the back end, what's going on is all this information is being pulled together from various systems. And the modernization, often you start by thinking, hey, what I got to do is I got to do integration. I got to try and make systems faster. But the idea here is that you're trying to make people independent. I'm going to give you the tools that you can use by virtue of just talking and asking questions, and that makes the process go significantly faster. So we're removing a bottleneck. Okay. On reading the unread, there are a lot of statistics out there. Many of them come in around 80%. It could be higher or lower depending on the organization. But there's a ton of data that's just in documents. So I've got PDFs, contracts, call transcripts, scanned forms. I'm always shocked these days at how well vision language models can deal with scanned forms, emails, and typically extracting that was just a pain. So we've done work like this at Synaptic where, okay, we're going to, here's a document, we're going to define a template, we're going to do OCR. OCR isn't great. We got to have a bunch of people in there doing annotations. But now you just need a language model and a prompt and, hopefully an evaluation harness to make sure that things are going well. And so you've shifted from, well, it's not in the database, we can't deal with it. It's unstructured to I can query it all at this point. And so that allows you to say, I've been paying to store all this data. Can I finally use it? So the world used to look like these things are easy to access. There are fields in the CRM, there's a billing status, and there's a relational database. I can write queries against that thing. Hard to access where thing like like support emails or an account manager is writing notes. And so in the age of AI, because I can take that unstructured data and I can either make it structured and jam it into a database, or I can do information extraction from it dynamically, where I just let the user specify their information need. And now the process is more aware than it was before. So the process knows what matters, not just what is easy to get. And so that's another thing. So the the sort of talking to it says, hey, I'm going to remove bottlenecks because I don't need to wait on others to bring me the data. Reading the unread says, well, you know what? That information that's in that text file is the most useful thing, and I can get access to that easily because of AI systems. Then in, gluing the ungluable, there's a lot of work in enterprises translating between systems that don't talk. And I find myself doing that all the time where there's data sitting over in this system and I pull a bit of information out and then I go to another system and try and pull information out to synthesize it. The interesting thing now is that we've got agents which can do reasoning and they can look around the world, they can observe information, they can think about what they should do with it, and then they can act across systems. And they can do that without formal integration. So you're always going to need humans to look at the edge cases. And the idea is I think you let the computers handle the routine aspects of it. The good news is that the agents are so powerful these days that much more of it is routine, and the human is really sort of only involved in the problems that are unusual. So instead of waiting for a 6 month integration project, which are very painful, and I've seen many of those in the past, it's like, okay, we're going to deploy agents in 2 weeks. So that integration tax on your business just gets dropped tremendously. And there's a lot more flexibility. So I think old school engineered integrations, they have these fixed schemas. With agents, you can be very flexible about your information needs, and maybe you can think about mapping things differently in different situations. So it used to be the case that you had CRM, support, billing, product, and you're asking questions like, is this the same customer across systems? Or why does the billing match what's in our CRM? Or what usage data belongs to which account? But if you've got agents, and these are my little agent icons, right? Those agents now can actually do all this dynamic work. They can understand the questions that are coming in. Is this the same customer across systems? And they can interact with one another to resolve ambiguity and to solve those problems. And then finally, deciding in context. So many people work with software on a daily basis. If you've got a salesperson, they're using a CRM, they're using Salesforce or something else. I'm not shilling for Salesforce. They just have a nice big icon. And so deciding in context means I'm going to surface the insight right where the decision happens. Is it my claim system if I'm an auto insurance adjuster? Is it the EHR if I'm a medical professional? Or is it the CRM if I'm a salesperson? There's not a separate dashboard. There's not another login. It's not in a monthly report. You're trying to minimize friction, and you're going to surface the information to make a decision in the context that the user is looking at where they need to make the decision. So you go from here's a report to here's what I think you need to do next and why. And oh, by the way, you are perfectly positioned to go ahead and act on that information because this is where you asked for it and this is where you're getting it. So decision quality is going to improve. You don't have to ask anyone to change their tools. And that's a big, like changing tools, giant non-starter when it comes to business processes. So here you can, oh, you're in Salesforce. Well, here's this information about Tim. We saw this. I extracted all this before. Looks like he might be on his way out. What's the recap here? So this asking in natural language means that you can remove waiting. I can be just me who doesn't know anything about the how to write SQL queries, and I can get the information. Reading the unread allows the process to expand awareness, to know more, to find the information that's actually relevant to making the decision or all of the information. The gluing says I don't have to think about sort of fixed integrations. The coordination can happen on the fly, it can be dynamically, and then deciding in context allows you to close the loop. So again, we're not, and notice what we're doing is we're not kind of replacing the systems. We're removing barriers, we're integrating, we're providing additional information to make the entire process go faster. All right, so, where do we want to go from here? Think about pitfalls. So, I think many times people pick the tool first. They pick the platform before they define the outcome. So I mentioned earlier that we do a lot of work in Databricks and we tend to lead with Databricks. A wonderful product. We've had a lot of great projects with it, but you always need to think what's the outcome we're looking for and then what's the tool going to be appropriate for. I think another thing that you see is proof of concept purgatory. So there are all these pilots and they just never reach production. And in my experience, the reason that happens is because the tools are such with generative AI that you can make an amazing demo. So I can spend a day working on something. I can go show it to a person in the C-suite and they go, "That's amazing. I'm glad it's done. Let's roll it out." But the thing that's hidden is that productionalizing things, especially at scale, is very hard. And so that distance from nothing to POC is much shorter than the distance from POC to final product. You have to think about data readiness. Turns out AI can expose lots of data quality issues. So when you start trying to pull data together and use it to make decisions, you start seeing the ugliness that's hidden because that data has been sort of lying there, not being utilized fully. You sometimes there's not an evaluation loop. You need to know if the model is doing the right thing. That's super important. Keeping humans in the workflow is vitally important. You can't just turn this thing on and go, okay, you're making decisions now. Another pitfall is that people not checking on it routinely. And then one big one is you need to have an outcome owner. So somebody who's accountable for adoption, not just deployment. Because we've definitely seen software get deployed. It should be awesome, but people aren't using it for various reasons. And so somebody has to be responsible. A person has to be responsible for ensuring that that happens. Okay. So what about a framework? I always think about, we have lots of conversations with people who say there are many, many things that we could do with AI as applied to modernizing our business processes. And the conversation always revolves around trying to look at two things. What's the business impact? So if we did this and we were successful, what would the ROI be? And then the other is feasibility. And we're always looking for something that's a good balance between the two. So I've got this thing in the upper right-hand corner there that says you want high feasibility and high business impact. Not always possible to achieve both of those things. I tend to think that the more important of the axes is business impact because if I do something that's very feasible, but very few people care, that's not going to get anyone excited. But if I can have something that has genuine business impact and I have to work a little bit harder to get it, I'll go for those use cases as well. So as you're identifying them, you have to ask questions about, do we have the data that we need and can we access it? Is there a human in the loop who can catch errors? Can we measure success in weeks and not years, right? So it's got to be something where it's very measurable. It can't be an opaque outcome. It's got to be, yep, we increased sales by 15% and that was our target. Or our profit margins went up by 8% and that was our target. And then finally, is there a business owner that's accountable for these things? And if the answer is no, pick a different starting project. So you need to have a variety of things in place to be able to ensure that there's success. So that's one way to think about it. Then what you can do is you can pick a workflow where people are doing stuff by hand. You can look at time, right? Look at time, errors, cost, and then ship a thin AI layer in 60 to 90 days. That's actually probably it depends, right? But it can be much less than that these days with depending on the problem that you're solving. Measure again and then do it again for the next workflow. So the takeaway here is that this modernization compounds. You don't have to rewrite anything. Sorry, that should be you don't have to rewrite everything to start. That is, I can spread a little AI on one piece of it, and if I can make that measurably better, then I can go spread AI on the next piece of it. All right. So what about tomorrow, right? So where would you start? I if you were going to go and try and do this thing, I'd pick a workflow where people are manually stitching systems together. Data exists, it's hard to use, or there's some slow decision that's being made. And then you just sort of look at these things. What do I need? Do I need users who are able to talk to the system and get their data more easily? Is it the case that people are being hindered because they don't have access to all the data? Are the parts or the pieces not able to talk to one another? Or am I making decisions sort of off in a corner with some spreadsheet that somebody threw over the wall? So you apply those things to solve this particular problem. And again, despite the fact I'm very pro AI, I think about AI professionally most of the day, every day. Don't start with AI, start with a broken process, right? Find the thing that that's broken that you want to try and fix, and then figure out how you're going to apply AI and these sort of four capabilities and which ones of them are going to be relevant. Okay. So, what about concluding thoughts? So now we're going to come back to peanut butter. So this is your old boring processes, right? This is this piece of bread that's been lying around forever. This is modernization without AI. You go, hey, I'm going to go buy an artisanal loaf. It's beautiful. It's expensive. Everybody looks at it and goes, ooh, that's nice. So there's your expensive new processes. That's the old way of doing it. In modernization with AI, you've got your boring old processes, you've got AI, and we're going to spread the AI around, right? So we're going to, despite the fact that it went from white bread to dark bread, I apologize. The idea is that we're going to put this layer of AI on things. We'll keep the underlying system intact. That is quickly going to make the processes more effective. You're going to have happier users. And you can always go in and replace some of the foundation later if you want to. But using AI as this sort of thin layer on top of your existing processes can get you very far very quickly. So what are the takeaways? Modernization doesn't mean that you're building new systems. It's like it's better processes. And it is the case that generative AI can reshape them without replacing everything. So Gen AI is going to allow you to change the experience, to make more data available, to reduce barriers to data access. And I think it's important to partner with people who've done it before, like Synaptics. So we do this kind of work all the time. Just people who know the space and can kind of think about how the AI approaches apply in your particular domain can get you there more quickly than you could otherwise. So, as a final takeaway, modernization, it used to mean rebuilding systems. Now it means you're going to make your systems finally work together more effectively.